Okay. IGMB question 2024, number 15B, Roman figure 1, that's for physics 2. You have it that in terms of resistance R, the temperature coefficient of resistance of a material when the temperature variations is not too large can be written as alpha, which is equals to R2 minus R1 over R1 change in temperature. Express alpha in terms of resistivity. Good. Now, this first thing that we need to do here is write out the formula for resistivity. Resistivity, rho, is resistance multiplied by area over length. All right, so from this point, we have a value here, which is R. We are asked to express this resistance in terms of resistivity. That is, all this alpha should be expressed in terms of resistivity. That is, I need to make resistance the subject of formula here now. So if you make R the subject of formula, you have R equals to resistivity multiplied by length over A. But looking at this, we have two major values for R. We have R1 and R2. So I'll give that to this. For R1, only what we change in this case is the resistivity because we are expressing alpha in terms of resistivity. So we are going to have resistivity 1 with length over area. Similarly, for R2, it's going to be resistivity 2 with length over A. Now we have the two values for R1, R2. Fix them back into what we are given in the question. What we have in the question is alpha equals to R2 minus R1 over R1 change in temperature. So anyway, we see R2, rho 1 resistivity, the first one over the area, and with this. So let's put in that value. That will give R2L over A, which is for this R2, minus resistivity 1 with length over A, all divided by, again, resistivity 1 with length over A multiplied by change in temperature. So what we need to do now is to take the LCM of the numerator. For the numerator, the LCM will be A. Then you'll be left with rho 2L minus resistivity 1L. Same thing, divided by what you have here is division. For the denominator, you have rho 1L multiplied by change in theta over A. So I need to turn this division to multiplication. So you have alpha will be rho 2L minus rho 1L over A times A over rho 1L change in T. So A here, cancel this A. Then you have alpha equals to rho 2 minus rho 1. What is common here? L. L is common multiplied by 1 over rho 1L also change in T. So therefore you can have L here, cancel this L. Therefore you can have it finally that, okay, resistivity will now be, which is alpha will now be resistivity 2 minus resistivity 1 over, this is also resistivity 1 multiplied by change in temperature. Now with this, you have expressed alpha, which is the temperature coefficient, in terms of resistivity. Okay, question 15b, Roman figure 2 again. A given wire has a resistance 2.1 ohms at 27.5 degrees Celsius and a resistance of 2.7 ohms at 100 degrees Celsius. The question now is determine the temperature coefficient of the resistance of the wire. Now, all you have to recall is from the previous question, we were given that temperature coefficient alpha is resistance 2 minus resistance 1 over R1 with change in temperature. So go back to this question. A given wire has a resistance of 2.1 ohm, that is R1, 2.1 ohms at, that is change in temperature, theta 1 is 27.5 degrees Celsius. Again, R2 and a resistance of 2.7 ohms at theta 2, which is 100 degrees Celsius. So what do we need at this point? Determine the temperature coefficient, which is alpha. How do I get alpha? I need to know change in temperature first. So bring this formula here. Alpha will be R2 minus R1 over R1 change in temperature. Note, this change in temperature is still same thing as the theta 2 minus the theta 1. So if you fix this into this, you have alpha will be, what is the value for R2? 2.7, R1 2.1 over R1 2.1, then open a bracket, theta 2 is 100 degrees Celsius minus theta 1, 27.5 degrees Celsius. So at this point, alpha here will be 2.7 minus 2.1. That will give you 0.6 over, then you have 2.1, open the bracket, 100 minus 27.5, that will give you 72.5. Is that? Okay, so at this point, you have alpha to be 0.6 over 2.1 times 72.5. That will give 152.25. When you divide this, the temperature coefficient will be 0.0039 degrees per Celsius. Why? Because the temperature is still in Celsius. All right, assume a straight copper wire 0.3 meter long. So in this question now, length of the copper wire has been given to us. Length L, which is 0.30 meter long, moves at a uniform speed of 4 meters per second. Speed has been given, which is speed V has been given as 4 meters per second, perpendicular to a uniform magnetic field of flux density, which is the magnetic flux density B 1.25 T. Now, what is the current flowing in the conductor when A, its ends are open circuited, B, its ends are connected to a load of 2 ohm resistors? Now, based on what we are given here first, we can get the induced EMF in this copper. So induced EMF is BLV. B here is the magnetic flux given as 1.5, the length of the copper wire, 0.30 times the speed is 4. If you multiply this together, that will give 1.5 volts. Now, this is settled for the first part, but you have a question that what is the current flowing in the conductor when it is an open